Now, finally, I'd like to talk about a particular theory called agricultural location theory. This is the first time in human geography class here we talk about a particular theory. But this theory is important because in the context of agricultural geography, students need to know about this particular theory. The theory is called agricultural location theory. It was initially uh, investigated by the German economist by the name of Van Thunen. Van Thunen was a German economist. He is also a kind of a farm owner. He bought a lot of farms, and he on his farm he experimented with growing kind of crops, and then calculate with these kind of crops how much he had to put in, how much he can make, and then he summarized his findings into this book called The Isolated State. And so that eventually founded the classical agricultural location theory. In his agricultural location theory, there are some important assumptions. One is that we have this homogeneous plane. That is, everything on this plane is of same quality, same fertility, same moisture, same temperature, and farmers also have same skill, same knowledge, same information. Everything is the same. Then you have in the middle of the plain, you have this city market, one single market that serves the only place where farmers can sell the crop to. Then beyond this plain is wilderness. That means farmers have no other alternative to sell the crops. So this is some basic assumption. From this assumption, I begin to analyze, okay, what are the rationale the farmers decide what crops to grow at what location. Now farmers have to consider that if they want to grow crops at a particular location, what are the reasons? Okay. So the things for farmers to consider is that after they produce any crops and sell the crop to the market, what is the total revenue that they can receive? Also, to grow the crops, they have to pay, they have to have land, they have to rent the land from landowners. How much they can have to pay for use of the land. Also, they have to ship their crops to the market, and that involves transportation costs. Also, how much profit they can make. Also, the production costs, such as the watering, higher labors, uh, either fertilizers and the chemicals and tractors, so on and so forth. These production costs. Given all these revenues and input, how they decide that at what location, what crops they should grow. Okay, so that is the question that Van Thunen tried to investigate. Now, let's say that we have two farmers. Two farmers, they have a farm at location A and B, at location A and B. So since we said that this is a homogeneous plain and also homogeneous farmers, two farmers, they grow the same size of a farm, they would produce same amount of crops. Let's say they grow wheat. They grow wheat. They would produce same amount of wheat. If they shipped the same amount of wheat to the market, they would get the same amount of total revenue. And that's why you see the total revenue is flat. Both farmers, the total revenue is the same. Total revenue is same. But from the total revenue, you have to take off the production cost, the labor cost, how much money you have to hire machine, the capital, and how much material you have to use. Again, because of the homogeneous plane, the amount of production costs for both farmers are the same. So you can see the amount of production costs for both farmers are the same. They are at a different distance from the market, but since they are homogeneous farms, the production cost is the same. See, it's the same depth, same depth here. Also the profit here also the same for both farmers. Since they are homogeneous farmers, they should earn the same amount of profit here. Try to find my cursor. So the profit for A is this deep. The profit for B is also this deep. Okay. So from the total revenue, after the take off the production cost, after take out the profit, what's left are the money for transportation and the land rent. So this part of money is the same for A and B. So the money for transportation and the rent is the same for A and for B. Here we begin to see the locations makes the difference. Let's move on to the next slide. Now on this slide, farmer A and B are here. You know, farmer A live closer to the market, so he needs to spend less money on transportation. And farmer B live further from the market, so he will need to spend more money on transportation. Okay, so farmer A spend less money on transportation. Farmer B spend more money on transportation. This last slide show that farmers A and B have same amount of money available for transportation and pay rent. This is the same. But now we know that farmer A spend less money on transportation. Farmer B spend more money on transportation. So from the same amount of money, farmer A spend less on transportation. That means that farmer A has more money left to pay rent. Farmer B start out with same amount of money for both transportation and land rent. But now, since B spent more on transportation, the B would have less money left to pay rent. And that is this. Money left to pay land rent is more for A, less for B, because B lives further away from the market. He spent more on transportation, he would have less left to pay rent. If there's farmers on all these locations, you have individual farmers. So you can imagine that this line would indicate that farmers from here to here, they would have less money available for rent since they have to pay increasingly more for transportation. So this line indicates farmers' ability to pay rent. So closer to the market, farmer would have more money left to pay rent. Further away from the market, farmers would have less money available to pay rent. Make sense? Okay, now let's move on to the next slide. Now, we just talk about one type of farmers. Okay, let's say that this is the corn growing farmers. They have this kind of a line that indicates their ability to pay rent at different locations. Now, if we also have wheat growing farmers, you can go through the same kind of calculation. Eventually, you'll come up with another line that shows that rent paying ability for wheat growing farmers. Now, see, this line show corn growing farmers' ability to pay rent. This line show the wheat growing farmers' ability to pay rent. Now, when you look at this graph, can you decide what part of land should be used to grow wheat, and what part of land should be used to grow corn, and why is that? Well, it's clear that here is a divide. The place at the places where the two lines cross is a dividing location. Before this point, the land should go to whom? Go to wheat growing farmers or corn growing farmers? It should go wheat growing farmers because uh, before this point, if you come to rent the land, the wheat growing farmers can pay higher rent, so they would get to use the land. Make sense? So if you come to apartment, you want to rent this apartment, and you are willing to pay $500 for the apartment, but somebody else said that I would be willing to pay $600 a month. Who would get to use the apartment? Whoever who are willing to pay more. So before this point, the wheat growing farmers can afford higher rent. So eventually they can bid off the land from the corn growing farmers. This is the most the corn growing farmers can afford the land. But this is the amount that the wheat growing farmers can afford. Therefore, they would outbid the corn growing farmers. So eventually they will get the land. So the land here will go to be used by the wheat growing farmers. After this point, it's opposite. After this point, the corn growing farmers have a high ability to pay rent. Therefore, they outbid the wheat growing farmers for land. So the land will go to the corn growing farmers. So that's the reason that this is a dividing point where we decide what crop should be grown and where. Now, this is simplifies the graph. What if you have three crops? So if you have three crops, that will use the same reason, use the same rationale to decide where the land should be used for what crops. Obviously, before the point of X, the land should go to the crop 1 because growing crop 1 give you the highest ability to pay rent. Farmers would outbid all other farmers for land. But between the X and Y, the land will go to farmers who grow crop 2. And after point Y, the land will go to farmers who grow crop 3. So that's, again, this is, we look at how the land is distributed to different crops just in one dimension. But in a two-dimensional world, this happens in all directions, And that's why we have this so-called Fantunen ring in the two dimension, because the same would happen in all directions of outside this city market. And this is simply what we call the Fantunen rings. And so this kind of ring comes from the economic calculation that eventually into a series of crop growing rings around the market center. The intensity become higher closer to the center and become lower when move toward outside. And in the original Fantunen ring, you can see what crop grow in different rings. In the center is the city, next ring is horticulture and dairy, and next ring is forest, because during the time of Fantunen, firewood is a major source of energy. So people have to transport firewood to the market, and therefore to reduce transportation costs, forests had to be closer to the market. Next ring is crop rotation ring, and next one enclosed field and field and grazing. So you can really see that a different ring, you have a different specialized farming system and specialized crops. Okay, so this is a perfect circle occurred when we have a homogeneous plane where everything is the same. There's no distortion, and there's no other geographical features. What if you have some geographical features such as rivers or mountains? Here you have rivers. Along the rivers, you can use navigation, river navigation, that would reduce the transportation cost. Therefore, the same crop growing ring will extend along the river, around the river. So that's why a perfect circle become extorted into all the different kind of elongated shape. So that's because the river serve as the median of transportation. So that's the Van Toonen's agricultural location theory. Then you have modern geographers. They want to investigate whether the Van Toonen's conclusion is true in the modern world. So they use Chicago as an example to examine whether we have this kind of ring-like structure surrounding a big central market. We can use Chicago as a city market, and they look at outside Chicago, you do see a series of agricultural regions, and each region have a different kind of farm system. You have a dairy, grain, and livestock, a mixed crop and livestock farming. Then you have a cash grain, corn, soybean. Then you have grain, livestock. You have hog and cattle raising. So they do see some kind of a change in the farming system outside Chicago, and they seem to be corresponding to the agricultural, the Van Toonen's ring, and so they see this as some kind of evidence that more or less support Van Toonen's agricultural location theory. The, you also can look at the agricultural pattern of the United States. You will see the East Coast, big urban region on the East Coast at the big central market, and surrounding this big central market, you will see, supposedly you should see different agricultural ring and this idealized situation, but in reality, what you see is somewhat distorted situation, not perfectly kind of ring-like structure, but somehow you do see this sequence of agricultural region, one after another, that reminds you of the agricultural ring that you would find in Van Toonen's location theory. So that also brings some, you can see some resemblance to Van Toonen's location theory. So people seem to find some evidence that lends some support to Van Toonen's agricultural location theory. This is a typical map of North America that you would see that there's outside of this big urban region we call megalopolis, you do see this sequence of agricultural region. So people see, there's seem to be some evidence that have some preliminary support to Van Toonen's location theory. But of course, we know that the Van Toonen's location theory hypothesized a homogeneous plane where everything is the same physical condition, same human and cultural conditions. We know that in reality, that is not the case. So the actual agricultural region that we see in the context of North America is formed for various reasons that include different physical conditions at different locations, also different technological, different historical reasons, also different cultural reasons. So fine-tuning the theory may have some truth in it, but it simplifies the real-world agricultural condition by uh, assuming away the variations in physical and social and cultural conditions. So that is a little too simplified, but we do learn something from fine-tuning theory. That is, location does make a difference in pure economic calculations. So on this map, you can see more clearly what factors are not considered by fine-tuning theory. First, you can see that this is uh, this is uh, agricultural region, and this is a map that shows different climate. Because of the climate have a strong influence on the practice of agriculture. So if you assume away from the influence of climate, you miss a very big picture. And on this climate map, you can see this tropical regions, these tropical rainforests, and this corresponds to this kind of slash and burn of agriculture. So agriculture is strongly, and here in the desert region that correspond to this kind of animal herding, and therefore climate have a significant impact on agriculture. You simply cannot talk about agriculture without thinking about the possible influence from not only the physical environment, physical environment, but also social and cultural environment. But fine-tuning theory does tell us that if everything else is the same, location does make a difference in terms of what crops uh, you grow at what locations. So location does make a difference in terms of geography of agriculture. So now this is the end of this class, and these are the terms and concepts that you guys need to check out from the textbook to prepare for the next test. Thank you very much. I'll see you next time. Goodbye.